this class, we will discuss about the solar energy applications. Whenever we want to utilize the solar incident radiation for any practical purpose, at first there must be a mechanism to collect that incident radiation. Most commonly, solar energy incident radiation will be stored or captured in form of heat, and that heat is utilized for several other applications. Now we will move to a slide regarding the solar energy applications. Solar energy applications. Methods of storing solar energy. One is solar energy is intermittent energy source and must be stored for later use. The various methods of storing solar energy are thermal energy, that is by sensible heat. The other one is in form of a latent heat. The other one is a chemical storage. Most commonly, chemical storage is a thermochemical storage. Next is by means of a fuel. Next is a hydrogen storage. And the other methods are mechanical storage, that is in a flywheel, in form of compressed air, or in hydroelectric storage. Next is an electrical storage, that is a capacity storage, battery storage, and electromagnetic storage. Now at first we will discuss about the mechanical storage systems, that is the storage of incident radiation in form of heat, that is a sensible heat system and a latent heat and a thermochemical heat storage. Sensible heat storage system, here there is a flat plate collector. Basing on the energy requirement, we may use series of flat plate collectors, and in the flat plate collector a water is moving, and here when the water is entering into the flat plate collector, it absorbs the solar incident radiation. Whenever it absorbs the solar incident radiation, the temperature of water will be increased. Now that water that becomes a hot water now moves from flat plate collector to a heat exchanger. From the heat exchanger, by means of a pump or by means of a gravity, the water moves from heat exchanger to flat plate collectors. So here within the heat exchanger, exchange of heat takes place to this load. So it may be a load, it may be any type of energy conversion system. It may be a water heating or a power generation or space heating. From the space heating, the cold liquid will enter into the heat exchanger. Now this cold liquid or air will get the heat from the water which is flowing through the other passage of heat exchanger. By exchanging that heat, this media temperature will be increased, and that hot media, air or water, will enter into the load or energy source. Here in case of a sensible heat storage in the total system, the heat absorbed by the media in the load circuit is only the sensible heat. That means there is no change in the temperature of media. Now we will go to the next energy capturing method, that is a latent heat system. Now let us see the slide. In latent heat storage, thermal energy is stored in a substance or a mixture when it goes a change of phase while the temperature remains unchanged. The heat that can be stored by unit mass per volume is several times greater than sensible heat storage. Now let us see the equation. A solid plus heat. We are giving the heat to the solid, it will be converted to liquid. From the liquid, whenever there is a necessity, you extract the heat, now it will be converted into solid. So a reversible reaction is taking place between the solid and between the solids to store the energy. Now we move to the next method, that is a thermochemical energy storage. Forward reaction is endothermic in thermal chemical energy storage. When the energy is required, a reverse reaction is performed, and that reaction is exothermic. Both reactions takes place at constant temperature. So now let us consider the equation A plus B by absorption to be changed to x plus y, and whenever you take the heat from x plus y, it will once again converted to A plus B. But here A plus B to x plus y is a forward reaction and x plus y to A plus B is a reversed reaction. Forward reaction occurs at high temperature when compared to reverse reaction. Now the next slide is nothing but a solar pond, which is the application of a solar energy. The first one is a solar pond. Most commonly solar ponds are used to prevent the problem of convective heat losses from the solar tubs. For example, here if you consider this, a solar pond, it is having a tapered cross section. So the cross section moving towards the bottom is narrowed. If it contains water, solar incident radiation falls on the water and the bottom surface is covered with a black coke. So the solar incident radiation is absorbed by this absorber. Because of this, the water coming in contact with the bottom surface will be at high temperature. Because of density difference or convection, the hot water particles will move top and the high density low temperature water particles which are lying at the top surface will move down. This is the common phenomena in water heating. But in the solar pond, in order to capture the heat, we are using a salt along with the water. This water can absorb the salt. We know that the solubility of the water at high temperature is more. Whenever the solar incident radiation is falling on the water, the bottom surface water will be heated up and their temperature will be increased at high temperature, which can absorb more salt. Because of this, the salt density is more, this water cannot move up. So in this way, it is possible to prevent the convection loss. Generally, the top surface temperature will be around 38 degrees centigrade, but the bottom surface will be at a temperature of 65 to 85 degrees centigrade. By creating or by making a solar pond of larger size, it is possible for us to use it for power plants. Now let us have a look. A solar pond having three zones. A surface convection zone, it is 0.3 to 0.5 meters from top surface, where salinity is less than 5%. The second zone is a non-convective zone, where it is from 1 to 1.5 meters from top surface, where salinity increases with depth. The third one is nothing but a storage. It's a lower convective zone. It is from 1.5 meters to 2.2 meters from top surface, where we are calling it a salinity zone, where the salinity is nearly 20%. The next one is an application of a solar pond. So here it is nothing but an electrical power plant used along with a solar pond. Here solar incident radiation from the sun is falling on the solar pond. We know that the bottom layer is nothing but a non-convective zone or a storage zone, which contains the water at 85 to 100 degrees centigrade. The water is trapped from the third zone to the evaporator, we may call it as a boiler. And the water from the boiler will be once again coming into the solar pond. Here boiler is nothing but an evaporator. It is mainly working as a heat exchanger. And in the secondary circuit, this is a turbine, this is a generator, a pump and a condenser, where the media which is used for circulation is a media having low boiling point. Most commonly organic fluids or Freon series is commonly used. Now the Freon series, the Freon fluid of the secondary circuit is flowing through the boiler. Hot water from the solar pond is entering into the boiler. By taking that heat, this organic fluid will be changed to a vapor. That high pressure vapor now enters into a turbine, where that high pressure vapor will be expanded. It will generate some mechanical work. the turbine shaft is coupled to a generator by means of a coupling. So generator will produce the electrical energy by taking the mechanical work from the turbine. So now the low pressure fluid will enter into the condenser. So due to the expansion, the vapor coming from the turbine may be a low pressure fluid. That fluid will enter into a condenser where it will be condensed. Now that liquid freon will send to the boiler once again. In order to cool the freon agent or an organic substance used in the power circuit, we are providing a cooling tower. This cooling tower will circulate the water to the condenser to condense this working agent. So by using a solar pan, we can collect the solar incident radiation, and that heat will be transferred to the organic fluid of the power plant. Now this organic fluid will change its phase to high pressure vapor. Now that high pressure vapor will goes to the turbine where it is expanded, it develops some work. That work is given to a generator which develops the required electrical energy. Now this low pressure organic substance will goes to the condenser where it is cooled, it becomes low temperature fluid that will comes to the boiler, and the circuit will be repeated for number of times. Now we will move to the another application, that is an applications of solar energy. The various applications are solar air heater, solar water heating, space heating and cooling, solar distillation, solar pumping and solar cooking. The first one is nothing but a solar air heater. Air is generally used as a heat transfer fluid in many types of energy conservation systems or conversion system. In drying applications and for heating of buildings, solar energy can play a significant role. Air is circulated in contact with a black radiation absorbing surface and receives heat from the absorber surface. Now let us see this figure. This is a solar air heater. Incident radiation is falling on the flat plate collector. Here we know that a flat plate collector contains the transparent cover which is made of fiberglass, and it will prevent the radiation of the heat from the bottom of the surface. Once the radiation enters through the transparent covers, it prevents the reflection. Now air from the outside is entering through this passage. Here the plate which is provided between the transparent cover and the passage is an absorber. We know that the absorber is covered with a black coat to absorb the solar incident radiation. By absorbing the solar incident radiation, the temperature of the absorber is increased. The air which is flowing at the bottom of the absorber will absorb that heat. Due to that, the temperature of the air is increased. Now that air will goes to the application or a device or a place where you are going to use it. In order to have a tracking of the sun, we are providing a flexible stand. It is possible to track the solar air heater along with the sun. We know that sun never be in the same direction. The direction of sun will be changed. By using this tracking stand, it is possible to change the position of the flat plate collector along with the sun. Now we will move to the next slide, that is a solar water heater. The main elements of solar water heater are flat plate collector, insulated storage tank, insulated pipes connecting to collector and tank. Now let us look at the solar water heater. Is a natural circulation type. Basically there are two types of solar water heaters. One is a natural circulation type and the other is a forced circulation type. Natural circulation solar water heater, this is a flat plate collector. Whenever you feel that one flat plate collector is not sufficient, we will provide a series of flat plate collectors. That is, a number of flat plate collectors will be arranged in series. Now water coming from the tank will enter into the flat plate collector. While flowing through this flat plate collector, the water will absorb the heat from solar incident radiation. Due to this, the temperature of water will be increased. Now the hot water will enter into the tank. We know that because of density difference, the hot water is always will be at the top. That hot water can be trapped for our applications. Whenever the hot water is trapped, cold water is make up into the tank, so the level of the water in the tank will be maintained. This tank is insulated to prevent the convection or radiation losses. The amount of water circulation purely depends on the elevation, that is at what height we are providing the tank from the flat plate collectors. Forced circulation solar water heater. The basic difference is, in case of a natural circulation type, the tank is to be kept at a higher elevation, but here we can keep the tank at our convenient point. Here a separate pump is used to circulate the water from the tank to the collector. Here a temperature sensor is provided to the pump in case of a forced circulation water. Whenever the temperature of the water at the bottom is higher than the temperature of the water at the temperature of the water at the top is higher than the temperature of the water at the bottom, the pump never comes into action. For that, we are providing a temperature sensor. This temperature sensor will sense the temperature, and whenever the temperature at the top is greater than the temperature at the bottom, then only the system will comes into action. So the major difference is, here we are providing a pump and we can keep the tank at any place. Another advantage is there with forced circulation solar water heater, that is the amount of water which can be circulated in the system can be managed or can be changed by means of pump. The solar water heater forced circulation is used for hotels, hospitals, hostels and factories. So whenever you feel that mass of water required is too large, generally we will prefer for forced circulation. Solar still is called as water distillator. The solar still capacity is 3 to 5 liters per square meter area. It is a suitable method to convert saline or salt water into drinking water. Now let us consider a solar still. This is a container which contains the salinated water. Here, whenever the solar incident radiation is falling on this glass plate, and it will pass through the glass plate and it will fall on the bottom of the tank. The bottom of the tank is provided with an absorber plate coated with black coke. By absorbing the heat, the water will be evaporated and the evaporated particles will move and will come in contact with glass plate. Whenever the evaporated water particles come in contact with glass plate, definitely it is at lower temperature, so that water will be condensed. That condensed water particles will move along with the surface of the glass plate and they will be collected in a separate tank. It is intended to carry the distilled water. So this type of arrangement is most commonly used to manufacture the distilled water from a saline water. The next application is a solar refrigeration system. So the total one is nothing but a refrigeration system, and this is nothing but a heating system. This is a generator. As you know, in a solar absorption or in an absorption refrigeration system, the major components are evaporator, an absorber, generator and a throttle valve or expansion device. The refrigerant vapor coming from the throttle valve enters into an evaporator where it absorbs the heat from the evaporator space. The condition of refrigerant will be changed to high pressure, high temperature vapor. Now this high pressure, high temperature vapor enters into an absorber. Absorber contains weak solution of ammonia. By absorbing the vapor, it becomes strong solution. Now this strong solution is pumped to the generator by means of a pump, where in the generator heat addition will take place by means of which the ammonia vapor or the refrigerant which is present in the strong solution will be converted to a vapor. That vapor will enter into a condenser and throttle valve and so on. This is a basic refrigeration system. But in a conventional system, heat will be given at the generator by the combustion of a fuel or from waste gases. But in case of a solar refrigeration system, we are using a flat plate collectors, one or more number, and that solar incident radiation will be converted to heat. By absorbing that heat, the hot water will flow through a heat exchanger in the generator. So here there is no direct contact from the refrigerant fluid and the water. So by absorbing the heat which is flowing, by absorbing the heat from the hot water flowing through the pipe, the refrigerant phase will be changed to vapor. That vapor will move within the refrigeration circuit. So in this manner, the solar energy is utilized to heat or to convert the phase of the refrigerant in the generator of a vapor absorption refrigeration system. Now in case of a low temperature power plant, so here this is a primary circuit and this is a secondary circuit, this is a power generating circuit, this is an energy supplying circuit. So solar incident radiation is falling on the series of flat plate collectors. The water which is flowing through the flat plate collector will absorb that heat, the temperature will be increased, that hot water will flowing through the heat exchanger, we may call it as a boiler. So by exchanging the heat, the water temperature will be decreased, that cold water will once again pump to the flat plate collector by means of a water pump. In case of a power circuit, there is a boiler, a turbine, a condenser and the pump, and the turbine shaft is connected to a generator. But the most commonly used fluid in case of a power generating circuit is an organic fluid, especially of Freon series. Why? Because their boiling temperature is very less. So let us consider the Freon is used in the circuit. So Freon in the liquid form is there in case of a boiler. So boiler will extract the heat from the hot water, so the Freon will be changed to its phase, so the result becomes high pressure vapor. Now this high pressure vapor from the heat exchanger now enters into the turbine, where the turbine, because of the expansion of this vapor, the turbine will develop some work and the turbine shaft is connected to the generator, so generator will develop the required electrical energy. After the expansion, the media coming out of the turbine is a low pressure vapor. Now this low pressure vapor will enter into a condenser. In a condenser, by circulating the water from the external or surrounding, so the temperature of the vapor will be trapped and the result becomes a liquid. Now that liquid is pumped to the boiler by means of a liquid pump. So the principle of power generation in case of a solar plant is very less, but here the installation cost is very much high. Why? Because much amount of Freon is to be pumped to the circuit and the amount of power which can be generated is very less. Now we will move to the next slide. The solar power plant power production capacity is 10 to 50 kilowatt, efficiency is about 7 to 8%, and collector efficiency is 25%, net efficiency is hardly 2 to 3%. Now solar space heating. Whenever you consider the solar space heating, it is of two types. One is a passive heating, the second one is active heating. Passive heating systems. Passive systems are favorable for areas where ample winter sunshine is available, unobstructed southern exposure. So unobstructed southern exposure. Sometimes in the buildings the south side walls are covered by shade of the besides buildings. So if the south side of the building is directly exposed to the sun and even in winters ample sunshine is there, then only we can use the passive systems. Next, the passive system is cheap and comfort. The substantial temperature variations may occur during the day. A passive solar heating system. Here, this is nothing but a south side wall. Solar incident radiation is falling on the glazed window, and from the space, the air is passing through the vents which are provided on the wall. One is at the bottom and the other is at the top. So we know that the low temperature wind, because of density difference, moves down. This air will move out through the bottom vent, come in contact with glazed window. Glazed window is absorbing the solar radiation. So this air will come in contact with window. The temperature of air will be increased. That air will move through the top vent into the room. So here there is no separate mechanism. The media which is to heat the space is directly come in contact with glazed window. So that's why we are calling it as passive solar heating system. Now we will move to the another example of a passive solar system. It is a cabinet solar dryer. It is nothing but a solar dryer. Here we can store some products. In case of a solar dryer. Solar incident radiation is falling on the plate. Here we can provide some products like chilies, onions, etc. And the air is coming from the bottom, and this air will come in contact with this glass plate, where it will absorb the heat. Because of that, the air temperature will be increased gradually. Now that hot air will move from the top vent. Now we will go to the active solar heating. In case of an active solar space heating, as we discussed, a separate media is provided. So here this is a storage tank and a flat plate collectors. From the storage tank, water is entering into the flat plate collector. The temperature will be increased, and that hot water once again enters into the tank. And the hot water is moving through the heat exchanger. The cold air come in contact with heat exchanger. Through the heat exchangers, the water is flowing. Some amount of heat will be exchanged from the hot water to the air. So the air coming out of the system is a hot air. That hot air will enter into the space which you want to heat. So by means of which it is possible to heat the space. But here the method is an indirect way. That's why we are calling it as an active system. Next application is a box type cooker. So it is a bottom box. At the bottom we are providing an absorber plate having a black coke powder coating, and there is a glass plate, we may call it a transparent cover, and there is a mirror to reflect the light once again onto the transparent cover. So this solar incident radiation is falling on the transparent cover. From the transparent cover, the solar incident radiation pass through to its bottom, and it is falling on the black body. This body absorbs the heat, so the product which are there in the spots will be cooked. So this is the best application for the solar energy and is used for in rural areas. So solar cooker advantages are: no attention is required during cooking, no pollution problem, little maintenance cost, literally no maintenance cost, food cooked is delicious with natural taste, and there is no loss of nutrients with this cooking. Next is solar cooker is having its own disadvantages. They are: food cannot be cooked in the night or cloudy days because of lack of solar incident radiation. Time required for cooking is comparatively high. Items which needs high heat and manipulation during cooking cannot be cooked. In this class, we discussed about the solar energy collectors, solar energy storage mechanisms, and solar energy applications like a solar cooker, solar distillator or solar still, solar power generation, solar water heating system, and solar direct energy conversion systems like photovoltaic devices.
Further clarification, contact